Hi everyone, what we're going to do today is take a look at number systems and then properties of numbers. So for the number systems, basically any number that you know right now is a real number. In math, we usually will use the capital letter R to represent the real numbers. And again, at this point, those are all the numbers that you know. At that point, we break numbers down into two subgroups. There are irrational numbers, and there are rational numbers. Irrational numbers are numbers that in decimal form never end and have no repeating pattern. So kind of think mumbo jumbo numbers. They just don't make sense. They're numbers that keep going on and on and on forever. They have no pattern. They're not nice, pretty numbers. In math, again, we'll use the capital letter I, to represent irrational numbers, a set of irrational numbers. And the most famous number that's irrational that you probably know at this point is pi. Pi is approximately 3.141592653, and it just keeps going and going and going forever. If you were to Google the digits of pi, it would be endless pages, and there's really still no end. They keep, finding digits all the time. So pi is the most famous irrational number. Another example would be the square root of 2. Again, if you were to look at the square root of 2 in decimal form, if you were to type it into your calculator, you would get a decimal that never ends and never repeats. And then something like negative square root of 101 would also be another example of an irrational number. So rational numbers then are fractions and decimals that either end or have a repeating pattern. So our rational numbers, we use the letter Q, I think because we've already used R for the reals. So Q is our set of rational numbers. And these are things like 1/3, because 1/3 as a decimal is 0.3 repeating. There's a repeating pattern when we look at 1/3 in decimal form. And then something like negative 0.67 or negative 67 hundredths. That decimal ends, so it is a rational number. And then something like the square root of 16. The square root of 16 is 4, so that is a number that ends, so that would be a rational number. Underneath that, we have categories. We have the integers, which we use the letter Z to represent the integers. Again, I was already taken by the irrational numbers. And those are your positive and negative whole numbers. So we go all the way from negative infinity, we have -2, -1, 0, and then we have all of our positive whole numbers as well, all the way up to infinity. Then we have our whole numbers, so we're going to use W for our whole numbers. And so those are basically starting at 0 and then using our positive integers. And then our natural numbers are our counting numbers. We use the letter N for natural numbers. And those are just our counting numbers. So 1, 2, 3, and so on. So down at the bottom of your paper, what we want to do here is name all the sets to which each number belongs. So 30, for example. Well, 30 is a counting number, so that would be a natural number. It's also a whole number. It's also an integer. It's also a rational number because it ends. And it's a real number. Okay, let's skip around a little bit. Number 2, -11. Well, -11 is not a natural number because it's negative. It's not a whole number because it's negative. It is an integer. It is a rational number. And it is a real number. So take a look at the numbers that you have there and go ahead and see if you can figure out what sets each of the following numbers belong to. List all the sets that each number belongs to. Take a minute, go ahead, push pause right now, and then come back and double check and see if you were able to put the numbers in the right categories. So go ahead and double check, make sure that you were able to put the numbers in the right categories. Just make sure that you have most of them labeled correctly. If you were unsure about some numbers, like the square root of 21, use your calculator, turn it into a decimal, get the decimal form of that number, and then you can tell what type of number it's going to be. So the next thing we're going to take a look at is organizing the real numbers. And so we have basically real numbers. All the numbers that we know are real numbers. So any number we know is going to go somewhere in this box. Then the numbers are broken up into two categories. They're either irrational or rational. And if they're rational, they can be integers, whole numbers, or natural numbers. So every natural number is going to also be in the set of whole numbers. Every whole number is going to be in the set of integers. And every integer is going to be in the set of rational numbers. But it doesn't work both ways. So for example, 0 is not a natural number, but it would be a whole number, it would be an integer, and it would be a rational number. Okay, so we're going to try to put them in the best location possible. So letter A is 7. 7 is a rational number, it ends, and it's one of our counting numbers, so we can go ahead and put it in that category right there. Okay, letter B, negative 36 twelfths. Well, if we simplify that, negative 36 twelfths, we end up getting negative 3. Negative 3 is an integer. It's not a natural number because it's negative. It's not a whole number because it's negative. It is an integer, which also then makes it a rational number, which makes it a real number. Then we have negative 36 for letter C. Negative 36, when we take the square root of 36, we get 6. So when we simplify negative 36, we would get negative 6, which is an integer. So we're also going to put that in that category. Okay, then we get to pi. Pi is an irrational number. It's the most famous one of our irrational numbers. E 6 48 hundredths. Well, that's a rational number. That's a decimal. It ends. It doesn't repeat. It's not a natural number. It's not a whole number. It's not one of our integers. But it is a fraction or decimal that ends when we write it out. So letter E is going to be a rational number. Okay, so go ahead and see if you can place the rest of those. I'll give you a minute to work on that and then come back and we'll share answers. All right, so just double check where I placed everything and make sure that yours match up with mine. All right, now let's take a look down at the bottom for some of these multiple choice questions. I do have the first two answers shown, but let's talk through them. The first one says, which expression does not name an integer? Well, an integer, remember, is a positive or negative whole number. So negative 15 is an integer. 0 is an. If we look at letter D, 12 divided by 6 is 2. So all of those answers, when we simplify them, turn out to be integers. 6 divided by 14 does not turn out to be an integer. And then for number 2, which expression represents an irrational number? Well, an irrational number has to either never end or never repeat. So the first one, 0.18 with a line over the top of it, that line over the top is telling you that it's repeating. So that would be 0.18, 18, 18, 18, 18, 18, 18, on and on forever. So that one repeats, so that would be a rational number. 2/3 in decimal form is 0.6 repeating, so that repeats. If we look at letter D, the square root of 3 minus the square root of 3, that's going to be 0. That's a rational number. And so the square root of 25, what we'd want to do with that one is double check, put it into our calculator, get the square root of 75 in decimal form, and then see if it is a rational number or an irrational number. All right, so try the other few that are on that page, and then we'll come back and double check. All right, so you should have the answers 4, 3, 4, 5, 6, 7, and 8. Just double check that you were able to come up with some of those.